Okay, last time we were talking about the different types of analysis which you can do with the level of service. Okay, and these are the types we can do: operational analysis, service flow rate and service volume analysis, and design analysis. And I told you which one you are doing for the term projects. Which of these you are doing for the term project? Yes. Which type of analysis you are doing for the term project? No worries. These are the equations for the analysis. In all of them, we are using the heavy vehicle adjustment factor. It's enough that I let you enter. You don't have to let all the voices enter with you. Huh? You close the door. Okay, so in all the analysis, we are using the factor for heavy vehicles. And this is the equation of the factor. We need percentage of heavy vehicles and the equivalency factor. The equivalency factor can be taken according to the terrain conditions. So if it is level or rolling, you can take it from here. And if it is gradient type, then you can take it from one of these tables. How do I know the terrain conditions? We have this flow chart given here. So from the flow chart, you check the condition, whichever condition satisfied, that is your terrain. We looked at a couple of examples how to convert the volume from vehicles per hour to passenger cars per hour. And we also looked at if you have multiple gradients, then how can you combine them. Today we are going to start with an example. The example is for a freeway. This one has 4 lanes, 10 feet lane width, letter clearance 0 feet from the pavement edge. If they say pavement edge or they say the roadside, close the door. If they say the pavement edge or the roadside, that means the right hand side. Okay, the pavement edge or the roadside means the right hand side. That ramps per mile are given, rolling terrain, the mix of the trucks is given 2%, peak hour factor 0.95, the peak hour volume is given in one direction, and it is this much, and they are asking for level of service. Okay, this is the operational analysis. Okay, this is what we call as the operational analysis, where you have a highway and you are trying to find out the level of service. Okay, now whenever you have these types of questions, the first thing you should be looking at is the free flow speed. Any type of analysis with level of service, the first thing you should look for is the free flow speed. Now, is the free flow speed given here? Is the free flow speed given here? No, right? Okay. So we are going to use the equation of the free flow speed for the freeways. So for a freeway, free flow speed equals to this. Okay, so I need some factors here. Which of these factors is given? Looking at the free flow speed equation, what do we already know from the question? Lane width? Lane width, okay. What else? The ram density, okay. The ram density is given here, 5 rams per mile. Okay, this is my TRD value. Now, as he said, lane width is given, but FLW is not lane width. It is a factor of lane width. So using the lane width, I will find out the factor. How much is the lane width? 10. And what is this FLC factor for what? Yeah, factor for what? The exam was a big shock, huh? Washed away everything. Yes. Very good. Yes. FLC is for what? What are these tablets for if you cannot even check this? Huh? I'm 90% sure that we are playing games on it, right? It has nothing to do with rubber. Huh? FLC is for what? Yeah. Believe me, I will not move forward until you can. Yes. For L for lane, F for fact, C for lateral clearance. Factor for lateral clearance. How much is the lateral clearance here? How much is the lateral clearance given? 0. Okay. So I will find out the factor for lateral clearance. Remember, it's a 4-lane freeway. Okay. So my lane width is 10 feet. So how much is the factor? 6.6. Then my lateral clearance is 0 feet and I have a 4-lane freeway. So how many lanes? 2 lanes, okay? One direction. So the factor is 3.6. Okay, tell me the free flow speed. PRD is 5 given.
How much the outing?
5. $52. Okay. Once we find this, once we find out the free flow speed, then we will see which type of analysis we are doing. We are doing operational analysis. So next thing we have to find out is the VP, okay, peak flow rate or demand flow rate, okay. What do we need here? We need volume, we need peak hour factor, we need number of lanes, and we need FHV, right? Okay, we need these things. So if I go here, Okay, tell me how much is the volume? How much is the volume here? 3000. Okay. Next thing, we need peak hour factor. What's the peak hour factor? 0.95. We need number of lanes. How many? 2. Okay. It's a 4-lane freeway. The volume is given for one direction. Number of lanes, one direction. Okay. Then I need FHV, right? I need FHV. Now for FHV, I must know the terrain condition. What's the terrain given here? What is the terrain condition here? Rolling terrain. Okay. And I must know the percentage of heavy vehicles as well. This is given as 2%. Okay. Now this is mentioned here what? Typical mix. Okay. What is a typical mix? Close. This is what we call as a typical mix. Okay. There are two types of heavy vehicles: single unit trucks and trailer trucks. There are already chairs here. It's what? Yeah. You already knew before coming in that these are broken. Oh. Single unit trucks, trailer trucks. Okay. Typical mix is single unit trucks are more, trailer trucks are less. This is what we call as typical mix. Okay, but it will, in this question it will not affect. Don't worry. But the other questions it can affect. Okay. This is the equation for the factor for heavy vehicle. Okay, I need percentage of heavy vehicle, which is given 2%. Okay, I need EHV, which is the equivalency factor according to terrain. Terrain is rolling, right? Okay, for rolling terrain, the factor is 3. Okay, so close the door. Okay, 2% per 2% trucks and EHV 3. How much is the factor for heavy vehicles? EHV is this one, right? Rolling terrain. 256. What do you do? 2% means 0.02.
1.02. 1.02.
Everybody has gone back. What did I do? 1 upon 1 plus 0. 2% is 0.02. Okay, and then 3 minus 1. What?
196.
196. This is 2% means 0.02 and this is 3. Okay, this is how we got 0.96. Okay, 0.96 makes sense. Okay, we were calculating VP, demand flow rate. Okay, FHV was required there. So VP equals V divided by peak hour factor N and FHV. Okay, V is 3000, peak hour factor given, FHV you just found. Okay, number of lanes 2. How much is the VP? Uh, 44. Sorry. $44, right? 1644.7. Okay. Because we divided with FHV, it became passenger cars. It was vehicles per hour, it became passenger cars. Because you divide by number of lanes, it became per lane. Okay. So this is how we are changing the units. Okay. Once you find out VP, now we are trying to find out the level of service. For level of service, I need flow and speed. I need what? Flow and speed. Do I have a value of speed? Do I have a value of speed in this question? No? No? FLWs. We found, right? We found free flow speed. Okay. Can I use this? Yes. Yes? Always. Always? Free flow speed means what? When do we have free flow speed? There is no jam, right? Who told me there is no jam? Who told me there is free flow? I don't know. So first I need to find out if there is free flow or not. Then I can take free flow speed. Okay, you have a volume, right? You have a volume. 1645, you have a flow. Okay. So I'm not sure. Maybe it's free flow, maybe it's not free flow. I need to find. Okay. To find this, I'll go here. Okay. There is a point which is called as the break point. If your flow is less than this point, your speed is free flow speed. If your flow is more than this point, your speed is not free flow speed, something which will come from here. Got it? So I need to check with this point now. Flow I already have, right? I already have the flow. I need to calculate this point which is called as the break point mentioned here. Okay. What is the equation of the break point? This is the equation. Okay. Now what is CAF? What is CAF? Correction adjustment factor. Sounds weird, right? Something wrong. Correction adjustment factor, it needs a correction. What adjustment factor? Capacity adjustment factor. Thank God you didn't say CAT adjustment factor. Okay. So capacity adjustment factor. Capacity adjustment is required when you have a condition for adjustment. Is there any condition mentioned in the question that we should apply adjustment because of this condition? It's not mentioned. Okay. So we will just ignore the factor. Okay. So give me BP. Same thing for the free flow speed as well. Even with the free flow speed, you can see it's mentioned, adjusted, but I'm not adjusting it because there is no condition. Okay, clear? So this will remain as it is what you have. So what is your break point? One eight. Okay, is it less or more than VP? More, right? Okay. So I am on the other side. I am on this side. So my speed equals free flow speed, which I already know. So I don't need to find out any more speed values. Okay. Now why I am doing this? Because from flow and speed, I will calculate density. Level of service depends upon density. Okay. So in order to find out density, I need flow and speed both. Now I found both of them. And I know that the speed is free flow speed. So I can find out density. What is density? Vp upon S. S will be free flow speed, as we already found. How much is this? Sorry? 31. That's not miles per hour. passenger cars per mile. Okay, tell me what is the level of service from the table, first one.
D.
Level of service is D. And this means, right?
Yes.
Okay, the level of service is D. Okay, clear?
Yes.
Any questions? Clear? Okay. Now, we said speed equals to what? Speed equals to what?
C0.
No. Here. Good. Free flow speed, right? Free flow speed is good or bad?
Good.
Good. What about level of service D? Good or bad? Not good, right? People who are not sure, I can give it to you. No problem. You can check later on how it feels, good or bad, once you get D. Okay? So how come the speed is good and the level of service is bad? Okay? Huh?
Length of the section.
No. It's because of the geometric conditions. Okay? The lane width was 10 feet and the lateral clearance was 0. Okay? This is the minimum, right? Lane width, if you go to the lane width table, you will see 10 is the minimum value. And lateral clearance, obviously, 0 is minimum. Right? 0 is minimum. So you are providing minimum widths. So that is disturbing the flow. Okay? And if you look at the ramp density was 5 ramps per mile. Okay? 5 ramps per mile. So that means if you divide the distance, okay, that means ramp after every few hundred meters. After every 300-400 meters, you have a ramp. Okay, so because of the road design and road geometry, you are providing a narrow road and too many disturbances, too many entries and exit points. Okay, so this is causing the level of service to go down. Clear? Or the driver are not feeling comfortable because of that. Clear? Okay. Now, let's say in this question, let's say now we took this highway from Bahrain and we put it in one of the tropical regions, Malaysia or something. Okay, they were asking it. So we took it from here and we put it there. Okay, but there they have what? Rain. Okay, something which we are looking forward to, right? They tell us in the news every day, it's going to rain. Just have patience. Have your cars ready and everything. Your brakes tested and everything, right? I did not do it. Anyways, let's say we took this highway. Now it's in a different region which has rain. Okay, so weather is a condition which requires adjustment. Okay, weather is a condition which requires adjustment. Okay, now if you look at the data, first of all we calculated free flow speed. Is there any effect of weather in this equation? No. So this value will not change. Okay, but free flow speed will change. Not from this equation. Once you calculate the free flow speed, now you will multiply the value with the adjustment factor of weather. Okay, so there is an adjustment factor for weather which is speed adjustment factor for weather. Okay, it will not change the equation of free flow speed, but it will change the value of free flow speed. So you will get the initial value from the equation like we did. Okay, and then you apply the adjustment factor. Now to apply the adjustment factor, I need to know the weather condition. Weather condition is, let's say, medium rain. It's written in the slides. I'm just trying to avoid changing the slide again. Medium rain. Okay, the top row, the first row. Okay, and then I need the unadjusted value of the free flow speed. My free flow speed was, how much is this? 52.8. Do I see 52.8 in the table? I don't see it. Okay, it's actually out of the table. It's not even between two values, right? Okay, so what do? We'll take the minimum value. We take the value which is for the minimum, which is 0.96. Okay, so speed adjustment factor is 0.96. Okay, so the free flow speed adjusted will be 52.8 into 0.96, which is how much? 50.7. Okay, if you look at the table, even if I gave you value, for example, 56 or 59, okay, you don't need to interpolate. If you look at the values, 0.96, 0.95, 94, 93, 93, so you can just round off, no problem. Okay, take the nearest value, no problem. Okay, this is what I'm doing here as well. Okay, so I changed the free flow speed according to the adjustment factor. Next thing we calculated was FHV. Any effect of weather here? Any effect of weather? No. Okay. Then I calculated BP, demand flow rate. Any effect of weather here? Yes. No, right? You're saying no effect or no, you don't know? Both. Okay, so this value will remain as it is. Then I calculated BP. Okay, for BP there was an equation. Okay, so, sorry. Okay, so there is, first of all, I will use the free flow speed which is adjusted, the new value, okay? And then I need capacity adjustment factor as well for the weather, okay? So, capacity adjustment factor, this one, okay? So, again I will do the same thing which I did for speed, okay? Again the value is out of the table, 52 point something is not here. So, I will use the factor which is for the minimum speed. Okay, what's the break point? $28 point. Huh? 1,800. 128. 58. Okay. Okay. My VP is still the same. Okay, break point has reduced slightly. It was 1892, now it is 1858. So reduced, right? But compared to VP is still higher, right? Okay. So this means what?
Speed is free flow speed.
Speed is free flow speed. Now which free flow speed?
Yeah, this is
52.8? No, the adjusted value. Okay. So my free flow speed is now
50.7.
50.7. Okay. So what's the density now? Tell me the density now with the new free flow speed.
32.4.
What's the level of service?
Same.
Same D, right? Okay, still D. So, but you can see free flow speed has reduced because of the weather conditions. Density has increased. Okay, more density means less spacing. Less spacing. This is again the effect of the speed. Drivers are going slowly or slower. The spacing is less now. Okay, so you can see that the overall traffic condition did not change, but the drivers are going more slowly now. Okay, they are still in the same level of service, but they are going slower. Any questions? Okay. Okay, the next question is for a multi-lane highway. A 4-lane multi-lane highway, it has a median, peak hour volume is 2600. Okay, 12 feet lanes, 4 feet clearance on the road side and the median side. I told you road side means the right hand side and median side is the left hand side. Okay, so 4 feet on each one. We have 10 access points per mile, 10% trucks, standard mix. Okay, standard mix means the same thing which I showed you. 70% single unit trucks and 30% trailer trucks. Peak hour factor is given. Segment has a gradient now. It has a gradient of 3.5% and a length of 1.25 miles. Okay, and the base free flow speed is given 65 miles per hour. What did I tell you? In all these analysis, the first thing we should look for is what? Free flow speed. Is it given? Yes. Yes. It's given, right? Should I take it? Yes? No. This is a multi-lane highway. Multi-lane highway, free flow speed is calculated in this way. So which value is given? Base free flow speed. This value. This is 65. Okay. So this is base free flow speed. Free flow speed is something else which we need to find out. Okay, FLW was the factor for lane width, right? Okay, my lane width is 12 feet. For 12 feet lane width, the factor is how much? 0. Okay. The next factor was for lateral clearance. For multi-lane highway, I need total lateral clearance. Okay. It was given 4 feet on the road side, 4 feet on the median side. Total 8. 4-lane highway, 8 feet clearance, 4-lane highway. Okay. The vector is 0.9. Okay. Next thing is the factor for median type and access point density. Okay, they said the highway has a median. So having a median means what type of highway from the first table? Divided. Okay, so the factor is 0. Access point, we have 10 access points per mile. Okay, so the factor is 2.5. Okay, tell me the value. 61.6 miles per hour. Okay. The next thing we find is VP. Okay, we are following the same procedure which I mentioned earlier. We are going to find out VP. Okay. For VP, V upon peak hour factor, number of lanes, and FHV. Okay, FHV equals 1 divided by 1 plus okay. Let us look at the question, what they are saying about the terrain. What they are saying about the terrain, it has 3.5% gradient and 1.25 miles length. Okay. They didn't say level or rolling, they gave us a value. Okay. If you have a value, then you go into this chart and see what condition you have. Okay, so if I look here, is my gradient more than 3%? Is my length more than 0.25 miles? Okay, so I have extended grade condition. Okay, so I will take the factor from the other tables. Okay, in the question they are saying we have a standard mix. Standard mix is this one. 70% single unit trucks and 30% trailer trucks. This is called a standard mix, typical mix, default mix. Okay, all these terms apply to the same thing. Okay, so we have, again going to the question. Now see what they are saying. 3.5% can be upward or downward, right? Now what they are saying, do the analysis for up and down both. Okay, but using the same values. Using the same value. How is it possible? Because we are expecting that this much volume will come in one peak hour in the upward direction and almost the same in the downward direction in some other peak hour. Okay, we have more than one peak hours, and usually in the morning and evening the volume repeats in different directions. Okay, so that's why we can take the same value for both directions. Okay, so we'll do it for upward as well as downward. Okay, 3.5% gradient, 1.25 miles length. Okay, 3.5% upward means positive, I am here. Then 1.25 mile length, I am here. Okay, I have 10% trucks. 10% trucks. So the value is 2.96. Okay, EHV is 2.96. This is for upward. Now downward means negative, right? Now if you go to 0 or -2 and look at the values, you will see the values are not changing. Between 0 and -2, the values are not changing. Okay, they are the same. Okay, so even if I have -3.5 or -1 or -4, it will not change, it will remain the same. Okay, so I can take the value of whatever value. Okay, 0, the value for 0, value for -2, it is the same. Okay, so in the old book they used to have just one row for all the minus values. They were used to having a row for equal or less than 0. Okay, but nobody was paying attention, so they made 2 rows. Okay, so you pay attention and get more confused. What do I do with -5 and -4? Okay, this is the only reason, nothing else. Okay, so 1.25 miles length and 10% trucks. My value is 1.96. Okay, for 0 it's the same, for -2 it's the same, for -3 it's the same, whatever you have. Okay, so 1.96. Okay, so now give me FHV for upward and downward both. Trucks are 10%. PHV is 10%. How much? Okay, and downward? Okay, then how much is VP upward and downward? Peak hour factor is how much? How much is the peak hour factor?
1.75.
For down? Only FHV will change. Everything else is same.
One six two three.
1, 6, 2, 3. Okay, we need to compare these values with the breakpoint to know the speed is free flow speed or not. So if I go there for the breakpoint, remember I'm dealing with a multi-lane highway. Multi-lane highway, the breakpoint is 1400. Okay, if I look at my values, both of them are more than this, right? Both of them are more than this. That means what? Now you are in this region, okay, and your speed will come from this equation. Okay. And in this equation you can see we are using what? Free flow speed, and we are using capacity. Okay, capacity will be calculated from here. Okay, so if my free flow speed is 61.6, what is my capacity? This value. What is my capacity? Nine what? 0.1. Okay. In that equation, I need the value of A as well. A is 1.31. Really? I'm asking you, please. I'm about to finish. Come in the next lecture.
Attendance.
Huh?
Please.
Yes, okay. Yes, please, I'm about to finish. Okay, what is the speed now? Tell me. Okay, DC is 45. Density and capacity, it is fixed, is mentioned in the chart. Okay, mentioned in the graph, it is 45. 45. Okay. Free flow speed is given, capacity, and you need the breakpoint. Breakpoint is 1400. Okay, it will not change. Breakpoint is 1400. Now keep in mind, because VP will change for upward and downward. That means speed changes upward and downward. Okay.
Only C.
How much?
D.
D is 45. It's on the chart here. It's mentioned here. It's always till I change the book.
54.54 down.
54.5
5.
for up. Up is more. Up should be less. 49. Okay, then we can calculate the D value for up and down as well. It is flow upon speed.
29.8 for them.
Why are you always going down? Okay, next, up, flow upon speed. How much?
35 point.
This is not the values I got in the other section. So up is 1759 upon 49, right? Okay, and down was 1623 upon 54.5, right? Okay. Now for both these conditions, you can see the level of service. Okay, for the upward condition, I've crossed 35, so my level of service is now E. And for downward condition, I'm in this range. Okay, my level of service is D. Okay, so there is a change in the level of service, but you should recheck the value, by the way. You should recheck the value. So this is the effect of the gradient. Obviously, whatever happens, but you can see the density is becoming higher on the upward side and the speed is getting lower, okay? Because upward, people are going slowly. They are slower, okay? Makes sense, okay? Now for the next question, we will not do it, but just want to explain a couple of points, so just give me a couple of minutes here. Okay, it's a design example. They gave me volume, they gave me peak hour factor, familiar users, 15% trucks. Okay, TRD is given. The segment has level terrain, and there is a segment of 2 miles which has a gradient of 4.5%. Okay, so we have two different terrain conditions now, a level terrain and a 4.5% gradient. Okay, can somebody tell me it changes what? In which value do we have the effect of terrain? Huh? Which value has the effect of terrain? I showed you the tables, right? Now we were getting the value of the factor. Which factor? Where are you using these factors? Huh? V? Which factor you are putting in the equation of V? This one, right? This one. Okay. So I have to calculate this factor for the level terrain, and I have to calculate this factor for the gradient as well. Okay. For the gradient, you can see the gradient is 4.5%, the length is 2 miles. Okay. Which is this condition, right? Length more, gradient more than 3%, length more than 0.25 miles. I have extended gradient here. Okay. In the previous example, you saw when we have a gradient, we did the analysis for both directions, right? Okay. So we will do the same thing here for upward as well as downward. So how many values of FHV we will have? 3. One for level terrain, one for 4.5% upward gradient, one for 4.5% downward gradient. Okay, bring these 3 values tomorrow. Tomorrow, not tomorrow, on Thursday. Okay, you have to calculate these 3 FHV values before you come to the class. Clear?